GAC, how we doing today? Precalculus 12. I hope all is well today. You'll notice that throughout this week that I am currently unavailable because I'm an announcement. I have a new baby. This is Emmy right here. That was the first day she was born. And maybe even at some point within one of these podcasts, I can introduce you to her. Words can't describe how much I love that little girl. And we're just so excited to have her a part of our life. And so this next week, I'm taking that time off just to be with my wife and be with Emmy. However, throughout the course of this week, you'll notice that I provide a lot of opportunities to where I know that it won't be as good as me being there. However, I think I can use some resources to help us out in that way. Some of the resources that you'll see include the following. You'll see podcasts that I'm posting here. You obviously have the answer sheets that you'll be able to look at for help on your homework. And then also at night, I rotated between Precalculus 12 class and Algebra 3 class and have rotated back and forth between those days to give about 30 to 45 minutes to answer any questions that you had on the previous section in class from the podcast. Again, I realize that this is not the perfect scenario. Obviously, I'd love to be with y'all, but unfortunately, or really fortunately, we have a little baby girl to where I definitely need to be home, and I'm very excited to be home as well. With that being said, I also know that the Monday I get back next week, there's a lot of people that have makeup work, and what we'll do is we'll make that, extend that time to where the makeup work we'll have next Monday and Tuesday morning from 7 to 8. If you have any questions regarding any of that, you can email me or text me, and I'll get back to you as soon as possible. So again, remember that. If you take a look at it, if you have any questions, let me know. But let's get started. We're going to go through section 9.1. Note that this section is 9.1A and B. It covers both today, Monday, and Tuesday sections there. So again, when you watch this whole video, you're watching both A and B. So this one's going to be a little bit of a longer one. So if you need to, you can kind of go through maybe the first few, do some problems, and then maybe you do part 2 tomorrow, or however you need to do that there. It's completely up to you there on that side. So with that being said, we're going to get started, and we'll kind of go from there. So let's get it rolling. First off, congratulations. This is our last section this year. I can't believe it. I'm looking at the calendar now and just cannot believe that this is our last test, last section here. I want to congratulate a lot of you because on the last test, we had very high test scores, and I was very impressed with the effort that people put forth. If you missed that test, again, next Monday and Tuesday, we'll do that and offer you that opportunity to get that done as well. Check out the review on that. Online. You could check out that podcast if you need to. But again, congratulations. This is our last section, and we'll go from there. Now, in this section, we call this the conic section. You might say, well, why is it the conic section? Well, again, we're going to look at the shapes that are created when we put two cones together. Now, if you look at this is a plane right here. You can kind of see it on this side. And depending on how the plane cuts the cones, you get different figures. For instance, on the bottom, you get a point, a line, two intersecting lines. But if you cut it across on one way, you could get a circle. If you cut it at an angle, you kind of get an ellipse. If you cut it kind of towards just like a corner off, we could get a parabola. And then if I cut it straight up and down, we'll get a hyperbola. So let me give you the big picture here. We're going to start off by doing a parabola. Then we're going to go to circles and ellipses, and then finally we'll finish off with hyperbolas. Now, a lot of this stuff we've already done before. You've kind of had some exposure to this. Other things like the hyperbola are things that maybe you've never even seen before. But I'm going to hopefully go through these in enough detail to where you can recognize the difference between all of these together. Also note that the schedule that I currently have up may be modified because I feel like we may need a little more time, especially with me missing this week, to be able to finish homework and then answer questions. So again, as we keep going, understand that the schedule is up there of what we currently had planned, but I'm also flexible to be able to change plans if needs be. All right. So with that being said, we're going to look at 9.1. Okay, so let me go over the big schedule here. 9.1, we're going to go over today and tomorrow. So this is Monday and Tuesday. Okay. On Wednesday, Thursday, that's block day. We're going to go over just a little bit on circles and ellipses. So we're going to look over that. And then finally on Friday, we're going to just start, okay? Just touch base on hyperbolas. We'll just start it off, okay? We might need a little bit more with that. But again, that's kind of the big picture that we're going for there. So without further ado, let's get started on our conic section. Now, you've talked about parabolas before, okay? You really have. We talked about it probably for the last 3 years or so. Well, this time we take it just a little bit further. We recognize not just a parabola that goes up and down, but also a parabola that goes from left to right. Now, just a couple things to know. First off, it's very important for you to recognize that something that goes straight up and down is with x squared. We've talked about reflections. We've talked about transformations. We know all of those things, but it's just important to identify that x squared is something that goes either up or down. The y squared, if the y is the part that's being squared, we got to know that it's either left or right. So depending upon whether it's positive or negative, again, that's what determines whether it goes right or left. But something that has something that's squared there is something that goes right or it goes left, okay? Notice here that on this one, something that is x squared goes up and down. So that's with a parabola there. Now, one thing to note about a parabola is, again, you kind of identify, like if I throw a ball or if I have this shape, a parabola shape, you can identify with that because it's equal distance from a fixed line. Now, this is something completely new. This right here, we call two things. We call it a focus and we call it a directrix. Now, focus and directrix are basically this. If I were to pick a point, let's say here, again, this is the dotted line is the directrix line and this is the focus. If I were to pick a point on this, let's say it's here on this parabola, that means that it will have equal distance to the focus and the directrix. That distance right there between those two will be what we call equidistance, or just like it sounds, equal distance from the directrix and to the focus. So that's what we're looking at here. So when we talk about directrix and focus and when I graph it, it's just something important to note there in moving forward, okay? All right, perfect. So also we have what's called a vertex. Vertex is basically the point at which it's either the highest or lowest, or if it's y squared, it's either the furthest left or the furthest right. And so that's kind of where our parabola begins, okay? So again, that's kind of just giving you a little bit of a background. Let's take a look at a couple here in a second. In fact, actually, before I do this, note that a lot of these, when we talk about our standard form, if we have something that is x squared, again, it's up or down, and if it's y squared, it's left or right. Now, within this, we see something that has 4p. Again, this is our standard form. Normally, if you see h and k, you know that that's where the transformations occur, both left, right, and up and down. You know that. But with the directrix and focus, this is something a little different. The 4p right here and right here, again, these are the same equations just without any h and k or horizontal and vertical transformation. The p is the distance between the vertex to the directrix and the vertex to the focus. And so if you look back here, this distance here, boom, and the distance here, again, it's the same thing, is the distance p. So again, remember that the focus always goes inside of my parabola where the directrix is always on the outside. And I think after I do a problem, I think it'll make sense here moving forward. So let's take a look at this one. All right, let's take a look at number 7. So in number 7, it says find the vertex, focus, directrix, and sketch its graph. So I'm going to put this here. I'm going to put V, F, and D. Okay, we're going to put that there. Now, within the vertex, notice that there is no vertical and there is no horizontal transformation. You might say, how do I know? Well, if you come back here, you'll notice, like, for instance, in this example, that I am transforming to the left 3 halves and up 2. Because remember, the transformation occurs opposite if it's inside of those parentheses. So because of that, we know that that's the case. That's where it would be. Well, there is no transformation here. So we know our vertex will end up being at 0, 0. So we're going to put a point there. Now, I always, when I do this, notice that the x is the part being squared and it is positive. So since it's positive and the x is squared, we know that this is going to go in the upward position. Okay, we don't know specifically, but we know that that's kind of where it's headed. Now, to find the focus here, that's where we look at the number that's outside of that x squared there. So we look at that number. In this case, it's 1/2. Now, if we remember, if we go back to our form, whatever number's on the outside, that transformation that occurs, we can allow for p to be equal to that 1/2, because again, that's kind of our form. And when I solve for p, what I can do now is find the distance of the focus from my vertex here and to my directrix. So again, that's not making sense, let's do this. Let's get rid of this 4. By dividing by 4, you can multiply by 1/4. And when we do that, we understand that p now equals 1/8. So if I'm graphing this, I know it's going up. We know the focus is going to be on the inside where the directrix is going to be on the outside. So if I look at this, I know it's going up, so I'm going to go up to 1/8. Okay, so right there. So this point started at 0, 0, goes up 1/8. This point would then be at 0, 1/8. That is my focus. Now again, since I know this is going upward, that's why the focus is here. Now that same distance, which was 1/8 here, is the same distance to my directrix, which will have to be -1/8. And I know this is it's gonna be tough, but this is a dotted line that goes straight across, and that would end up being y equals -1/8 as my directrix line. Okay, and so what I have now is I've got the 3 things I need: my vertex, my focus, my directrix, to be able to graph this thing completely. Again, how do I graph it? I've only got a vertex. Well, at this point, what I would do is I would graph, just make a little t-chart, just throw a value in. Doesn't have to be crazy. We could just do maybe 2 of them. So if I plugged in, let's say 1, okay? 1 squared would be 1. 1 times 1/2 is 1/2. So when I plug in 1, I get out 1/2. So I'll go 1, 1/2, right there. Now let's do just 2 here. If I plug in 2, 2 squared is 4. 4 times 1/2 is 2. Okay, so I get 2, 2. Now, if I come up to this direction on this side, okay, on the other side, it will kind of do the same thing. So it goes right 1, up 1/2, left 1, up 1/2, okay? This one goes right 2, up 2, so we'll go left 2, up 2. And after I graph this, you'll notice, oh, that's bad, but you get the idea right there. It will look something like this in orange. So again, I've got my graph, check, my vertex, check, focus and directrix. And notice again, what does the focus and directrix mean? Pick a point anywhere on this parabola, and the distance between the directrix to the focus will be the exact same. Okay, and again, that could be used in a lot of different things, sometimes satellite or something of that nature. You know, again, that just helps us within this parabola to describe it even more specific, okay? All right, stay with me now, because right now I know you're working hard. I'm going to go over 2 more examples, and then if you want to, you can stop it, or you can continue on to the next part if you want to keep going there. Let's do the next one, which would be number 11. This time we've got to get it into our standard form. Our standard form is getting x squared by itself, so it should be x squared equals -8y. Again, just like before, we look at our vertex and we notice there's no transformations with y or with x. So because of that, we know we'll have our value at 0, 0. Now coming back to our focus is whatever p is. So we're going to set, again, -8 equal to 4p. Divide by 4, divide by 4. P equals, or p has a distance of -2. Now that's important, because if p has a distance of -2, we know this is negative, so no longer will it go in the upward position. It's still going to be up and down because x is squared. So, but because it's negative, this thing is going to go down for real, okay? It's going down for real. Sorry. It's my crunk music. Apologize for that. All right, so since p is -2, we're going to go down 2. We're going to mark it there. So we know this parabola is going down in this direction. Remember this distance, which is P, is -2. So we know that our directrix is going to be up here, and it's going to go left to right. Remember, this is like a y equals line, okay? So it's not, this is like not a point. This is more of a line with our directrix. So our directrix is y equals +2, where our focus is 0, -2, okay? And that's why a graph helps us when we find these three things. Now, last but not least, we come to the problem. We notice it goes down, so we're going to we know it's there, so let's plug in a value. Again, 2 is sufficient. We don't need really much more. So let's go plug in 1, and let's plug in like 3. So if I plug in 1, come back up here. I'll make sure, where are we? And actually, yeah, let's do this. Hold on just a second. As I look at this, I might actually have to go back to the previous one, and I'll show you why here in a second. And I apologize for that. But notice the form has to be x squared equals and y squared equals. I did it right on this one, but on the top one, number 7, actually was a little off because I set 1/2 equal to 4p. That's going to throw it off just a little bit. And so I'm going to come back to that one and fix it. But this one is correct. So stay with me. Let's see what we can do. So on this one, we plug in 1. And when we plug in 1, we end up getting something that's a little different because since it's equal to x squared, it's a little bit tougher to be able to do it. I think we can I still think we can do it, but let's just see what we got. So plug in 1, we get 1 equals -8y. Divide by -8, we get -1/8. Okay? All right, we got that there. Plug in 3, we get 9. 9 divided by -8 is -9/8. Okay? So it should be 1, -1/8. This is going to be really wide, but that's okay. And 3, -9/8, or -1 1/8. So this kind of comes this way, and again, kind of push it over to the same side. So write 3 down to about right there. Again, if you want to use decimals, I'm fine with that too. But that right there would be our parabola. Again, our focus being here, and our directrix is the line y equals +2. Okay. Again, here's the big thing. Okay. X squared equals -8y. Is something just focus in on, okay? It's got to be equal to x squared. On the previous one, let me go backwards, and I'm really going to go back here. So just kind of bear with me. On the previous one, on number 7, notice that I messed up, okay? And again, it's just, there's nothing else I can really say other than I messed up on that. So if you remember on this previous one, see if it's going to allow me to, nope, I don't want that. Sorry about this. Apologize there. And I'm just going to show you again, everything stays the same on this. The only difference on number 7 was the fact that I set 1/2 equal to 4p. The reason why I can't do that was because if you noticed, it was y equals 1/2 x squared when it should have been, we have to have the x squared by itself. And so with the number 11, that worked out to where x squared equaled -8y when I subtracted -8y to the other side. Whereas with number 7, I would have to multiply by 2 to get rid of that 1/2 and then set that 2 equal to 4p and then solve from there. Now again, it did not affect anything within my graph at all. It's just the new part with the vertex, with the focus. So come back here. What I'm saying is this. Everything in orange stays the same, okay? Stay the same there. The only difference is what I did here and here. Now, a lot of you will make the same mistake I did because you'll forget. So we've got to get this x squared by itself, and in doing so, have to multiply by 2. So we're going to multiply by 2 on both sides, okay? Multiply by 2. To get 2y equals x squared. Now this is the form I need. I can set 4p now equal to 2 instead of 1/2. So we're going to come back here. 4p equals 2. Divide by 4. P equals 1/2. So really what that does is instead of having 1/8, now we're just going to have 1/2. And instead of having -1/8, we have -1/2. So that's really the only difference, where this is y equals -1/2. And this is, the focus is at 0, 1/2 there. And it doesn't really change my graph, because you can just say that it's at that 1/2 part. But again, the only difference, make sure, and this is the form you can kind of see, x squared equals 4py and y squared equals 4px, okay? All right, before I go to the next part, here's what I'd like for us to do. I'm gonna go to one more problem, number 17, and then afterwards I'm gonna take a quick break, because I just got a text from my wife that I think Emmy needs some help here. So let's go to this one, and then we'll go from there. Now, again, we want the x squared by itself, or whatever's being squared by itself, and we've got that, right? We've got it, which is perfect. Now look at this part. The only difference now is that 4 that we're looking at, that 4 is the part that we set equal to 4p. So let's do this first. Let's do the vertex first. Remember, we have some transformations now, okay? So the transformation is going to go left 3/2. So we're going to go -3/2, because we do opposite, right? And up 2, because we look opposite from -2. So we go up 2. So left 3/2, or 1 1/2, and up 2. So we're going to go right there. That's our vertex. Since this 4 is positive and the x is being squared, that is why it is going upward. We'll look at one where it goes left to right here in a second. So once we have -3/2 too, we've got to find out what the distance is from that focus from the vertex. Since it's going up, the focus should be heading up in this direction, because it's got to be inside my parabola. So I'm going to set 4p equal to the value on the outside. Again, it's got to be equal. X squared's got to be the other side, or whatever's being squared's got to be the other side. And I'm going to divide by 4 to where my distance, p, would be 1. So this means that from this point, from the vertex, we're going to go up 1 right there. And for the directrix, we're going to go down 1. So it really is this right here. It's going to go side to side. Again, this is y equals for the directrix, which would be y equals 1, because it goes through that one spot right there, just that line. So we know it's going upward, okay? We know it's going upward. And we know that this was -3/2 too. But remember, the -3/2 didn't change when we went up. The only thing that changed was the y. So what we're going to do is we're going to just add 1 to this too. So we should have -3/2, comma, 3. Okay? So we got that there. We got all 3 of these things. Okay, we got those. Now we've got to determine what is the 2 points. So I'm going to plug in, just real quick, a point. Let's plug 0, and I've got to hurry up here. 0 and 2. So if I plug in 0, plug that in and see what you get out. Okay. Once I plug in 0, I should get 0 plus 3/2. Then I get it squared, and so on and so forth. It might be easier too to even plug in for y on occasion as well. But again, that's completely up to you. That's again, when you plug that in, see what you get out, and then we'll go from there. Okay. Tell you what, I'm going to pause this real quick. What I'm going to do is I'm going to get it in the next podcast down below. So check out the second podcast, and I'll finish this problem and keep it going. All right. All right. Thank you so much. I'll be back.